Welcome back. All right, when we last left off, we were talking about how the solar system formed from a cloud of gas and dust called a nebula, force of gravity pulling things together, stuff started to spin around, material got compressed so much, nuclear fusion occurred, turning the sun on. We had this accretion disk around this rotating blob of gas and dust that started to segment out, and those segments eventually became the planets. Now, let's talk about Earth and Earth's formation. So, following that same pattern, clumps of stuff coming together. So, early Earth was just a big, mixed up bunch of stuff. It took time for Earth to kind of settle down, form the Earth as we know it. And when it did form, it actually formed different layers. So that's what we're going to talk about in this section. So a good approximation of how Earth formed is just taking a glass jar kind of full of water, dirt, rocks, shaking it up, kind of early Earth, everything settling, and then once that kind of coming together material kind of slowed down and everything was collected, well, things started to settle. Things started to settle down, and Earth actually had a chance to kind of level out. Now let me show you a little bit what I'm talking about here. So after early Earth started to settle down, well, thinking about this kind of might be kind of hard to see here. Let me see if I can do any justice here. Oops. But if you think about it, if I have a jar full of, let me go back to this other one. If I have a jar full of rocks and dirt and water, well, where's all the heavy stuff going to go? Well, down here at the bottom. All right, all the bigger pieces of rock and dirt fell to the bottom. Well, where's all the lighter stuff going to go? Well, up to the top. I don't know, it might be a little bit hard to see here, but there's little floaty pieces right along the top here. So when you got a jar full of water and dirt and stuff, well, the heavy stuff goes to the bottom, the lighter stuff floats to the top. Well, same thing with the Earth. Hold on. Okay, here we go. Maybe this works. Okay, now I got my flashlight. All right. So, looking at Earth now, once things began to settle down, well, what happened? The heavy stuff went to the bottom, and the lighter stuff kind of went to the top. You can see some floaty things up there on the top there. Well, the Earth doesn't necessarily have a bottom, so where did all the heavy stuff that Earth was made out of go? Well, it kind of went to the center. Where did all the lighter stuff go? Well, it floated to the top. So what we're walking on, the crust, the mountains, continents, all this stuff, that's the lighter stuff. That's the lighter stuff that floated to the top. The heavier material kind of sank to the center of the Earth. And in doing so, just like this jar of dirt and layers and rocks, let me go back to it, one more time. You can see now that it kind of formed different layers. You got the bigger pieces down at the bottom, a little bit finer pieces here. Then you have some muddy water, and then you have some floaties on top. So you can see that even this jar of stuff kind of differentiated, kind of segmented itself out. Heavier stuff down here, you can kind of see the bigger pieces. A little bit smaller pieces of sand. Then you got muddy water and the floaty stuff on top. So the jar itself differentiated, separated itself out based on heavy stuff versus light stuff. Same thing with the Earth. As you know, that early Earth was forming and everything was coming together, it was just a hot bowl of mess. It was just a hot, just magma, just very hot, liquid rock material, because you got all this stuff colliding, coming together. So it was very hot, melted material. But once that collection of material and the accretion disk slowed down, once that accumulation of material stopped, well, that process of bombardment stopped, so there was not as much heat being transferred to kind of this forming Earth. So things could finally start to settle down. And when it did, again, the heavier stuff sank kind of to the center of the Earth. The lighter stuff floated to the top. And that's the process called differentiation, the layering of Earth or planets based on the chemical composition. So it's not necessarily heavy versus light. It's actually dense versus less dense. but you can kind of think of it as more the kind of more harder, I take that back, the just the heavier, more dense material kind of sank, just like when you throw a rock into water. Rock is denser than water, so it sinks. And then the lighter stuff floated to the top. Like when you throw a leaf in water, well, it floats on top because it's less dense than water. Water is more dense. So this layering, this differentiating occurred with Earth. So we have the crust, which is the outermost solid layer of Earth. It's very thin. It's a very thin, almost like if you think of a thin candy shell on an M&M. Well, same thing with Earth. The crust itself, even though we see these mountains and large continents, and we think of it, oh, it's got to be so big. It's actually very, very thin as compared to the different layers of Earth. So you do have this very low density, rocky, the lighter material, solid crust making up the outermost layer of Earth. So just below the crust, we have something called the mantle, kind of the middle composition layer. It's an intermediate density. It's mostly solid. It's rocky, but it does move a little bit. So kind of think of like hot Play-Doh with rocks mixed into it. You can kind of move it, and it kind of moves and stuff, but the rocks and stuff in there kind of grind, but there is some motion to the mantle. And then as we get further in, we get into the outer core of the Earth, which is very high density. It's metallic. It's actually liquid. It's actually liquid metal, liquid iron, and nickel. And if it wasn't for this liquid outer core, our Earth would be burnt to a crisp by some sun's rays, because this moving liquid outer core actually helps to create a magnetic field, almost like a force field, to help protect the Earth from some of the sun's nasty rays. And then finally we got the inner core, which is, again, high density, also metallic, also mostly iron and nickel, but it's solid material. So you have the solid inner core, you have the liquid metallic outer core, then you have this mantle around the cores, which is, again, like hot Play-Doh with rocks mixed in. It does move a little bit, but very slowly. And then you have the thin candy shell, the crust, right on the outside. Other planets in the solar system exhibit differentiation. Kind of crazy how we know this exists. More on that later in the semester. But a good summation here is, again, the crust is just a very thin shell. Then you have the mantle, which is still mostly solid, the liquid outer core, and then the solid inner core. All right. More on all of this, and we'll build on this model as we progress in this and other units. But before we go, I want to give you a super secret code. And the super secret code is 1111. 1111. That's 4 ones. 1111. You might be asking yourself, why the heck is Professor Kovac giving me this super secret code? What's it for? Well, each unit, after the lecture videos, you are required to do an assignment. It might be a reading, might be a video, a combination of both, answering some questions. In order to access that assignment, you need to use the super secret code from the lecture to access that assignment. It's just my way of keeping you honest. It's my way of trying to ensure that that you watch the videos. Now, I will be nice for this first unit. There are still a couple more videos, but we'll just call the code 1111 for the assignment. Make sure you still watch the couple of additional videos after this one. However, in units moving forward, I might not give you the whole code in just one video. I might just give you one number in the first video, another number in the second video, maybe skip the third video, give you another number in the fourth video. It's just my way of keeping you honest and making sure that you watch the lecture material. The lecture material that you watch, not only listen to, but also watch, all right, is going to be beneficial and built upon in the assignment. And both of those, that knowledge may be very necessary when we get to the lab. So when we get to the lab settings and you're working with a group, you want to work with someone who's put the same amount of work as you have. You want to work with someone that has the same kind of baseline knowledge as you have. This is my way of doing it. I know it's kind of weird, but this helps to ensure that you're watching the videos, you're paying attention, and while you're learning the material, you're also getting the codes to help you with the assignment. So if you ever get to an assignment, you put in the code and the code just isn't right, you miss something, all right? please ask. If some I make mistakes, so sometimes I put the wrong code in versus what I say in the videos. All right, but before you ever ask me, hey, your code is wrong, just double check that you really watched and listened to the videos. Not only might I say the code, I might hold up like a little piece of paper or board with the code on it. And so if you're only listening to the lectures and not watching, you might not even know that I just held up a piece of paper with the code on it because you're only listening, you're not watching. Remember, I'm telling you, watch and listen to these things. Just soak it in. You don't have to take notes. Just kind of just be present and hear about this material. We will build on this content knowledge. Remember, content knowledge is probably the least important thing I could teach you in this class. Critical thinking, problem solving, group dynamics, public speaking, scientific literacy. And you'll hear me say those a lot. That's what's important. The content, not that it's not important. We still got to learn a little geology. It's just the least important. All right? So, therefore, when I'm giving you these lectures for you to watch, just watch them. Just kind of sit down, watch them, just soak them in. If you need to take notes, if you feel you need to take notes, go for it. But I will tell you this, I learned a whole heck of a lot more in college when I just stopped taking notes and I just kind of paid attention and I was just invested and interested and kind of, put myself into the material as best I can. So in any case, so for future units, just keep an eye and ear out for the code. Again, I might mix it up. I might, again, give you, pieces of the code in all the different videos. I might wait to the last video. I might only do it in the first video. I might give you a code, and then at the end of all the lectures, I might give you, it's like, say, hey, whatever code I gave you, multiply it by whatever, or subtract some numbers from it, whatever it might be. So, again, it changes weekly, or it changes every unit. Just be, but you're gonna get the code if you're just being present and doing what you're supposed to do, watch and listen to these lectures. All right. Well, that brings this short section to a close. Now we got the layers of the Earth. So we talked about the solar system formation, the Earth's formation as it started to settle down and began to layer into the kind of heavier and more dense inner core, the a little bit less dense liquid outer core, the mantle, and then the crust is just a little thin part on top. All right, well, we'll pause there. When we come back, we'll talk about the different systems that operate on and within the Earth that is going to help us understand how geology kind of plays a part in many facets of Earth. I will see you back here in just a minute.